This will be a very quick and dirty run through of why it's cool, what you can kind of do with it, and I'll show some examples. This is pretty much going to be a quick run through of the first part of the workshop that I did for one of our clients that was looking to adopt GraphQL. Really, we're going to look at what I think is a better way to think about data. And it's been a long time coming, as this was originally built at Facebook and open sourced in 2015. So it's actually been around for a while, but like most things, it takes a while to kind of percolate up, hit the wider audiences. I love new and shiny, so I really took a liking to it. So the case for GraphQL really is better thought of as like a comparison against REST. So with REST, I'm assuming that everyone has familiarity with working with APIs. You have certain RESTful principles depending on what you want to follow. There's version that you have to worry about. You have the contract for the endpoints and how you want the data represented via your API. You have data concerns, which primarily boxing that in as what shapes you return, how much data, how you want to paginate for someone or return lists. And then of course there's documentation for especially if you're making an API that's consumed by others, you want to make sure that it's clear what your endpoints receive and then what they send back. So to kind of further drill into this, there's a bunch of questions, and this list of leading questions is basically what most people will discover as you're developing a new API or as you read about how these things should be done. So to start off with, essentially, how strictly should you adhere to the principles of REST? How do you decide which ones are important? If you look up REST in general, you'll probably see a lot of contention about whether you should follow particular formats, whether you should group your endpoints in specific ways. And there's a lot of kind of dogma around it in some senses. If you really want to get strict with your REST implementation or do like something in the more real world, which we'll look at briefly. And then how should you handle versioning, or should you bother? This deals with, do you want an endpoint where you want to end up bringing new, possibly breaking changes to your API, and then how you should version that? Do you want to present that API where you might have, how long do you keep something around that's kind of a legacy API? Do you allow different clients access to different versions? And then how do you want to structure your objects, right? So what is the shape of the data that works best for your clients? And this is in particularly, like as far as versions, it kind of ties in with that, because you can create a RESTful endpoint that returns a set object shape. But if that's not exactly what your customer wants, or you're sending them a lot more data than they need, then you maybe need a different endpoint, or you need to get more complex with your REST implementation. Like JSON API, for example, where you want to be able to send what fields you do or do not want. And there's solutions to this, but they get kind of tedious. And then further, are you sending appropriate data? Are you sending them information they don't need? This is specifically ties into a lot of the questions that GraphQL ended up answering when it was developed, and we'll look at that. And then relational hierarchical data. Are users able to efficiently query that? How do you deal with nested structures if you have objects that are very commonly returned together? Do you force the client to call for the parent and then iterate through, let's say, a user and their list of friends, right? And then go back to the server for each friend? Or do you go ahead and just return it all as a batch? Just because those objects are separate, but do you want them to be represented in a different way? There's lots of questions about how you handle endpoints like that. And then again, as far as documentation, are users able to easily figure out what API endpoints are available or how they should be used? Keeping this up to date is tedious. There are tools for generating this, but again, you have to work that into your system, your structure of when you make the API. That way, those things can be effective and up to date for the consumers. So I contend that fetching lists with REST is verbose and or tedious and or mysterious. A lot of it comes down to whether and what parts of it you consider to be best practices. But overall, I actually think that these are more like commonly tolerated situations. They're things that we've learned, we've followed as far as REST and REST implementations, but I really think that moving forward, GraphQL is a better way. So just to quickly go over a nested data example, we've got multiple endpoints for games and reviews. You can look at these and say that they follow pretty standard RESTful structure. If you want to nest down, you go in and you can route them however you want. There's some other examples. You could get the games, and then you could get the reviews, you get the ID for each one, and then you follow through and get the review for their specific endpoints. And what I've seen ends up being closer to this, which is you can have games. That second one, you could use JSON API, for example, or something similar, and say that I want to include reviews with those games. Or you could just make an endpoint called games and reviews. But then you end up with permutations where you end up wanting more data, or maybe something's named wrong, or who knows? It doesn't really care. So you could go ahead and just return some data with a post if you want to. There's not a kind of specification around how to do this. So a lot of the meaning can get lost if you don't do it quote unquote correctly. Updates follow a similar trajectory. Which verbs you want to use, how strictly do you want to use them. In all of these examples, you could just post if you wanted to. Again, that's not RESTful, and you have to decide whether that's something, whether you want to be RESTful or not. So either ambiguity or dogma are inherent in REST by nature, just whether or not you want to follow the structure, recommendations overall. And that comes down to conventions versus flexibility. What you want to follow versus how flexibly you want to be able to present things to your API clients. So yeah, we'll move on to GraphQL and see how sending and receiving data can be fun and intuitive. We lose a lot of baggage when introducing GraphQL. So as we move through this, I'll probably breeze through it pretty quickly and we can do questions at the end. So what is it and why should I care? This is probably the best succinct introduction, and I'm going to kind of break this down a little bit. So a query language for your API. That's what GraphQL says it is, because this is from the website. So GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. That first part is essentially that this is an alternative for getting data. It's an alternative to a RESTful API. It is not a database abstraction. Despite the name, it is not a graph database. It really just means that it presents your data in a way that forms a graph, as multiple types can all be related to one another. GraphQL provides a complete and understandable description of the data in your API. And this comes through its schema definition language, which we'll look at. This is how you assign and relate types to the particular types of data that you have. It gives clients the power to ask for exactly what they need and nothing more. I alluded to this just a little earlier. This has to do with what's called overfetching and underfetching. So overfetching is when you might have in RESTful land an API that returns a bunch of data for a user. In the case of someone maybe showing like a profile card or some small trivial example like that, you may only need the first and last name and maybe a URL to their profile picture. If you send a bunch of extra information, you're essentially wasting resources, whether they be bandwidth or if someone's on a data cap, or really just extra network time. And if you have a largely scaled app, that can add up. So GraphQL allows you to prevent that by only asking for the data you need. And then underfetching has to do with the chattiness of a RESTful API, especially if you follow a RESTful convention. Or like we looked at before, if you get a game and then with that game, you might get all the details for the game. You might get a list of reviews. So the reviews, you don't include those, but you do provide the IDs. So then you have to go back to the app and request all of the different reviews, and those create network requests for each one. Now you can get around this by massaging the endpoints or what you return, but GraphQL allows you to really do both or at once, right? You can ask for games, but then you can also say, I want to include all of the reviews for this game. And then it makes it easier to evolve APIs over time. This mainly has to do with the deprecation feature, which is built in, which allows you to say that certain fields are not meant to be queried anymore. And you can provide that message to your client so that they can adapt their applications to handle the future removal of a certain field or type. So you don't have to worry about versions. And then it enables powerful developer tools. This, I think, is kind of bearing the lead a bit because if literally nothing else on this page existed and we could just get the developer tools that this GraphQL framework, spec, whatever you want to call it, if we could get just the tools, it would be all worth it. And my demo is going to cover really that, because I think, especially among our group here, if you've worked with APIs, you kind of understand the limitations. But I think that the tools aspect is the one part that really makes GraphQL stand above and go well beyond anything that you can get with REST, unless you follow the strictest of RESTful implementations. So some key concepts: types, resolvers, and tools. So we'll look at types. So GraphQL is a spec. It has a basic type system as part of it, and it starts with some scalars. So you have some basic ones: string, int, float, boolean, and ID. ID and string are functionally equivalent, but they do have different types because certain tools would be able to make safe assumptions if you delineated something as an ID versus just a string. And then those scalars can be combined to form types. So on the example on the right is a movie. So you have a title, a poster, and a rating. Those are denoted with their types, and then the exclamation mark says that it's non-nullable or required. And that would be if you were sending data or if you're using this type in a query. So some other features: we have comments, deprecation, as I mentioned, enumeration types. So you can have maybe a user authorization level, for example. You could have like an admin, an org member, and a regular user. You can denote those as part of the schema. And then you have interfaces. So you could say, have a bunch of different movie types and have them all hold to a schema to make sure that, for example, they all have an ID and a title. And then variables for queries and mutations, which we'll look at. So then resolvers. Resolvers are how you send and retrieve data using an API. And like an equivalent in a RESTful API, these can use a service. You can connect to a database and get some data. You could call another API, whether it be GraphQL or a legacy RESTful API for a particular type, like a movie. This is a resolver for a movie, would be where you fetch data. And we'll look at an example of this. So then queries. Here's some basic queries. You can see the movies with a title and a poster and a rating. And when you get movies returned, you return an array of them. All right, well, I was going to try to denote. So you'll notice that part of the advantage of this is the structure is the same, right? So we want a list of movies, and we want a title, a poster, and a rating, and that's repeated for each one. So if we add or remove a field, it adds or removes to the response. So whatever we send is what we get back. So we can request for as little or as much data as we want. Mutations follow a similar format. You can really name it whatever you want. You can pass in an argument, and the resolver that you write would be able to return back the response for that movie after presumably marking it a favorite. So the next important part is that types enable tooling. So the advantage here is that because the schema has all of the types and everything involved, as part of it, you can introspect that schema to allow for things like code generation, where you can generate TypeScript types, for example. You can, many hosted services use these to provide some safe assumptions about whether you want to generate a database or connect with another service. You can do analytics. So because you can specify things at the field or type level, you can, for example, know which fields are more often requested by a certain client. So when it comes time to change the API, you might be able to prioritize what would have the smallest impact, or whether you even need that API anymore. If no one ever requests the phone number field, for example, maybe you deprecate it and not worry about supporting that particular feature. Database generation is also possible, and all of this is essentially enabled by the type system because it allows you to have certain conventions and safe assumptions made, because you can always be sure of the correct types that you're dealing with, rather than, for example, a RESTful API where the response could change at any time and you won't actually know in the same way. So some brief trade-offs. Learning curve. This is obviously a big one, and why lunch and learn like this exists. It's new, and for a lot of people probably don't have as much experience with it. It's just a different way to think about how APIs happen. right? So, and then there's query resolution and error handling. Those are slightly different. To a GraphQL API, every request is a post request. Most of the time, unless it's a 500 error, every request is going to succeed. It will just possibly come back with an error object. Now, certain GraphQL clients will handle this differently, but those are the types of things that may not follow exactly what an HTTP response would need to look like by default. And then caching. This early on was a larger concern. I don't think it's quite so much anymore, but it is something where a lot of the browser has or implementations have HTTP style caching built in. GraphQL, not so much in all cases, but a lot of times you can get around this by using a good GraphQL client. So now I'm going to do like a brief application tour and take a look at what a schema and everything looks like. So I have an example app, and this is in our Keyhole repo. You all can go download this and play with it. It's the demo app for the workshop that I gave. And if I remember where it is, in the API, we have a pretty simple schema. So like I mentioned before, you can have different types. So you can have a movie type, you can have credit type, which is for each person, it's a cast. Brackets around it mean that it's an array. So in this particular case, you can have a possibly null array of cast members, but each individual one must exist. So you aren't going to have any entries in there that are null. At the top level, we have a query. We have some query items, which you can name whatever you want. And I think this is most interesting to me because it kind of gives into a lot of real world situations that you might find in REST, where unless you're following a super RESTful structure, you may end up with something that's like movie with reviews or get movie by ID or movie by ID. There's no real convention established about whether, for example, you'd want the word get in front of this or to denote whether you should always have the name of the thing you're getting after it. It's really pretty open to however you want to do it. And I think it kind of gives into a bit of the overall ambiguity that's inherent anyway, like people are going to be people. So you might as well just let them do this. I kind of find that refreshing. So mutations, and these are the two, query and mutation here are two kind of special top level types that basically hold queries that then resolve to particular ones. So in this particular example, I'm using Node to use Apollo server to create a GraphQL API. And I have it running. So here on the left, you can see GraphQL Playground. So this points at the port 4000/GraphQL and allows us to see our schema again and see the same thing replicated in here. And then we have docs. So the nice part about this is that because the schema can be introspected at runtime or even downloaded and cached somewhere, and just you can introspect that file if you want. For example, here it is in JSON format. You get essentially discoverable, clickable GraphQL or documentation that is not out of date because it's on the server. You can click into any types. You can see the different items. You can see cast. You can click into this and you can see each one. So it gives you the nested structure that you can kind of click around and explore, which I kind of like because the discoverable nature of this allows you to play with it a little more, but that's docs. So if you want to, for example, query for some movies, you can start typing query. You can give it a name if you want to, and you can hit like Control space, and it'll give you what is available, right? So if we just did hello, I can either hit this play button or I can hit like Command Enter, and that'll return our basic Hello World resolver. If I want to do something else, I can say some now playing movies. It's going to immediately give me an error because I haven't selected any subfields. So I'm going to go ahead and do that, and I can hit Control Space. So all of this is auto-filled for me if I just hit them, auto-completed. So if I hit Command Enter or hit this, I'm going to get all of the movies. Now, say I wanted hello at the same time. I can totally do that. I can get any combination of data that I want. If I want to, for example, get this first movie here, I can say that I want an ID for this. Go ahead and get the same subfields, or maybe just the cast. And then that's going to tell me that I need a subfield actor name. right? So you can get any combination of data that you want. If you think this is ambiguous and you know you're going for a specific one, you could, for example, alias this if you want to, and then that matches here. So, as you can see, it's really flexible. If I only want a certain amount of data, I can just only get what I want. If I want a whole bunch of data and a bunch of different combinations of things, I can get that too. And the nice part is that, you aren't paying the same sort of performance penalty that you would get in REST if you were, for example, returning movies and the cast members, and then the client, only wanted to use the title of the movie. You're essentially sending a bunch of extra data and throwing it away. In this case, if I don't want this movie, I delete it, and then that resolver for the particular movie isn't even being hit. Same with this. So what that looks like, in essence, if anyone's familiar with a Node API, it looks pretty similar. It's based on Express. So in our example, I can new up an Apollo server and give it the type defs, which is my schema. I can give it a map of resolvers, and then I can give it any data sources that I want. In this case, the movie data source. So I know we talked about resolvers, so let's look at that. So over here, we have a resolvers map that takes a map of items. We have a query, mutation, and a movie. If we look at our schema, our kind of top level, we have a query, mutation, and a movie. So that one-to-one mapping is what allows us to follow this convention, where hello is the same as hello, now playing is the same as now playing. And we can use whatever we want in these particular resolvers to grab our movie data. So in this case, we have a movie data source that's using a now playing method. So the data source is right here. And we have our movie data source. In this example, we're using the MovieDB API and just saying I want to use this API with this key and go and get the first page of now playing movies whenever I request now playing. So I'm requesting to an API, and then this resolver is going to another API to return the results. Popular works the same way, movie by ID, get credits, and so on. So that's the basics of a Node API on the backend. And because this is a spec, there are implementations available for Java, for example. In Spring, there's a Spring GraphQL module. There's a couple implementations for .NET. Node is going to be the kind of gold standard, just because it's what the actual GraphQL JS kind of reference implementation is built on. It'll probably always have features first before the others. And so if you want to check this out, I would look at this example. If you want to go off on your own, I would recommend starting with Node to get your feet wet. And there are also other alternatives like Hasura or AppSync that allow you to get started with a GraphQL API very quickly by pointing at a database, which is also super powerful. Part of the relational nature of the types in GraphQL lend themselves very well to relational databases. In this case with Hasura, which I'm a big fan of, it will actually introspect your Postgres database and grab all the tables, attempt to set up relationships for you among different types. And then you basically have a GraphQL API that you can just point at and use nearly for free. It's pretty cool. And then when we get into an actual application development, I want to give a quick look at, in this example, React. If you've done any front-end work, React is pretty popular. I don't see that really changing anytime soon, but the most popular client to use as Apollo server on the back end is Apollo client on the front end. So in this case, just like we had a query in our playground, you can also use the same query, and in this case, I'm using a fragment where I can declare a set of things that I want to return for a movie, and then reuse this little sub-selection of fields wherever I need to. In this case, in the popular movies and in the now playing movies, I'm getting the same movie structure each time and just including it. And what this lets me do is basically provide that query and pass it to the use query client hook along with some types that I've generated from our schema, and it gets me a data and loading structure that I can kind of walk down and have type safe access to the data that I'm requesting. And this is the tool part that when I first discovered it kind of totally blew my mind as far as what I was used to working with in REST, and that is you can, by using these tools, have a UI that does not runtime error for data issues. Because you can introspect a schema and say, for this particular component example, I know that my query is going to be this. I know that it's going to be these particular fields. And I know, because of the schema, which of these particular fields are going to be possibly null or not. I can make sure that I'm safely accessing all of the structure. If I go to the movie poster and I pass in a movie, I can generate that type where I have the movie of a known type generated for me by the tools, to where now if I have props.movie, I know that it's type of movie and I know favorite is a Boolean or null or undefined. And that's the same for all of these different types. In this example, poster path is required, so it's not possibly null or undefined. It's going to be there if it gets to this point in my application. That alone it really opened my eyes to what a better way of doing front-end development especially. That particular trick is accomplished through a tool called GraphQL Code Generator. You can give it a YAML or JSON schema. You can give it some plugins, and when you tell it, I want to spit out a bunch of GraphQL types, I can go to this generated GraphQL.tsx, and it's going to look through all my files, find all of those little GraphQL query section pieces that I've made, all of the queries and mutations and everything, run through these plugins and generate me a bunch of code. In this case, documents and types and things I can use in my application that match for everything I want to use, including even entire hooks. So the alternative there is, instead of saying use query and passing it my query myself, it already knows that I have this query, so I can just get a hook generated for me where I don't have to worry about using the types. This has been automatically generated for me. It already uses the use query hook. It already has the proper types. So I literally just say use popular query and I get my data. It's very simple. And it's just a couple of tools, and that's due to the safe assumptions they can make because GraphQL is a spec, because GraphQL is typed, because you can follow these safe conventions and make assumptions about it in tooling. That's my quick and fast run through. Did anyone have any questions?
And Matt, this is Casey. I tried doing GraphQL. It looks like it really simplifies the front end and cleans up the bandwidth and everything. But my struggle was with the back end. Looks like you've got some new tooling there. I don't know, is that newer, like how it maps to databases? I don't remember seeing that before.
There's not any kind of database mapping, but
because that was my big challenge was actually setting up a GraphQL server. I mean, especially when you get into authorization and that kind of stuff, it seems like that was the part I struggle with, trying to figure out how to structure the back end.
So luckily, I made a course for this about authorization. Shameless plug.
Cool.
And I think it's actually a free weekend this weekend for Pluralsight. So you guys could check this out as well. In general, it uses a lot of the same patterns here, but goes through authorization levels. And yeah, the short answer to that is it is not less complicated than REST when it comes to the things that you have to do for an API. It just moves them and structures them in a different way to make a lot of it easier to do. It's not like a cure-all for the troubles of REST in general. There is some structure, and there's tons of boilerplates and all sorts of things that I would recommend that you check out. Getting a particular authorization scheme set up, or even just knowing how to structure your resolvers. Right? There's tons of resources online. A couple other local KC peeps did companions to this. So there's one about setting up a server by John Mills. He runs the KCDC conference with some others. And then Aditi did the client course, Apollo Client. She's also based here in KC.
Hey, Matt, this is Dave. Yeah. You talked about a couple of products that reverse engineer a relational database, I think Postgres, into what? Is it the graph?
Yeah, it essentially makes you a server.
Then the client has those ready to consume GraphQL APIs, right? That they can just do CRUD and through the GraphQL language, right? So it's ready to rock. From a client standpoint, after you do that, is that true?
It's really quite quick. I know there's tools that point at them, but I have a feeling that you would probably need to make your own resolvers and do something like what I've done here. Another good JavaScript or TypeScript implementation is Nest.js. If anyone's familiar with that, it's been kind of a popular API framework lately. It looks a lot like Angular, so it scares me, but I have seen a lot of people that have enjoyed it and use it at the current client I'm at, and it's nice in general. The one non-SQL DB implementation that's pretty popular is AppSync, which is something that I've talked about before. I've given a lunch to learn on that. It's kind of been a couple years now. That uses DynamoDB, but at least the initial implementation, they kind of cheated. They just made a bunch of DynamoDB tables and then used GraphQL as the relational part of it, right? So they weren't really using the NoSQL DB as a NoSQL, but you get all the tools out of it. So like no matter how you do it, you're still operating against what at the end of the day is a specific schema with specific types. So you can really like not care about how some of the data is resolved, especially for legacy clients. Like I have a feeling that a lot of what we might encounter is moving people from a more legacy API to a GraphQL API. And where this really shines is what I've shown in the REST example, where regardless of whether you're starting a new API from scratch, which by the way, if you are starting a Greenfield API, I personally see zero reason why you would ever consciously start a new RESTful API ever again for everything I've talked about here. I feel like that's like trying to start a new car company with horseless carriages or something. It'd be crazy. The tools alone just make it so much better. Any other questions?
One other thing, you were talking about not versioning, doing some kind of deprecation. Did you have an example of that?
Yeah. So in here, for example, here's the schema. Queries. I think I did it because it's gone now.
So what does that mean? That it's no longer in there, or that it's just kind of in there and giving you a warning? How does that work?
Essentially, here it was. Yeah, field query.hello is deprecated, no longer supported. So you can pass a message, and basically any client that interfaces with this is going to see this warning. If they query it, it'll come back in the response as a warning. If they point their tools at it, you'll get a warning similar to this.
Yeah, and you can customize the reason on the annotation so that, like, if you say, we've deprecated this in favor of some other field, use that field or something, you can put a reason on that annotation as well.
Right. Any other questions, people? That's my quick and fast run through.